So here comes part B. Same instructions. Find the area bound by the curves. So we are given y equals x squared, y equals x plus 2, and x is between 0 and 1. Okay, well, I recommend go to Desmos, graph y equals x squared, y equals x plus 2, and graph x equals 0. Well, that's just the y-axis. Then also graph x equals 1. Okay, let's see what that would look like. All right, I just have the first two, y equals x squared, my parabola, y equals x plus 2. It's the line going through 2 with the slope of 1. And then for the vertical lines, well, 0 is right here on the x-axis, or excuse me, the y-axis. And x equals 1 would be somewhere like right, I think it's somewhere like right there. X equals 1. Something like that. So then after you have these things graphed, I highly recommend you do a sketch and then you shade the region that you're looking for. And I'll tell you, I mean, that it may seem silly to do that, like overkill. I've been teaching calculus a long time, over 10 years. And let me just tell you, go ahead and shade that region to make sure you got it right, because you might think like, well, it's silly. Like, who would ever get the region, identifying the region wrong? Yeah, I've been teaching this class too long. Like, plenty of people choose the wrong region. um, so which is it going to be? Okay, so remember, it's going to touch all four boundaries, x squared, that, and then, okay, so where here does it? And well, I can't like, kind of ask yes or no, or like tell me if I'm getting warmer or colder. Um, I just got to go ahead and shade it. It's right here. It's right here. Okay, so I'm between the two vertical lines, and I'm between the parabola and the slanted line there. Okay. All right. That's really going to help me when I go to set up my integral. So here it is. Area equals, well, I'm going from 0 to 1 on the x, 0 to 1, starting point, ending point. What's on top? It's actually the line that's on top. So x plus 2 minus x squared. Really, at this point, just getting that region correct with the drawing and setting it up, that's what's new in this section. From here, it's just a matter of taking antiderivatives. Nothing too challenging about this. And then plugging in the numbers. So if all of this makes sense, then you're doing really, really good. Of course, more examples to come. Let's go ahead and simplify this a little bit. Most people like to put the highest power of x first. I'm one of those people. So I'm going to say negative x squared plus x plus 2. Just make it look a little bit cleaner. And then I'll go ahead and do the antiderivatives, and not really going to walk through them. Just going to present it here. So the negative x squared, negative 1/3 x to the third. The x becomes plus 1/2 x squared, and the 2 becomes plus 2x. We evaluate from 0 to 1. Okay, so let's go ahead and plug all that in, and this step is quite long on the page. But what am I doing? I'm plugging the 1 into each of the x's. Subtract, plug the 0 into the x's. Okay, takes a little time to write all that out. Now what's nice though, the 0, all of this just disappears. So when you grab a calculator, it's really just there. And the fact that it's a 1, really, what does it boil down to? Just negative 1/3 plus 1/2 plus 2. I mean, that's really all you're doing. And so I just went for it. And the answer to this one, the area is 13 over 6. That's pretty cool. I mean, that's kind of a cool little area. I mean, it's got the, got the slant, got the curve. 13 over 6. Like, who would think that it's such a simple area? Okay. So these first two examples have been the easier variety. We're going to do a couple more, a little bit more challenging, take it up a level. All right. This first one, I'm going to still use y equals x squared and y equals x plus 2, but we are no longer told boundaries of x. Well, what are we going to do with that? I mean, how are we going to get the region? How are we going to get the a and the b, the limits of integration on the integral? Exactly. Okay, so that makes it a little bit harder. Well, you begin the same way. Go ahead and graph both of these. Well, if you've got Desmos up, just erase those two vertical lines and you'll have it. So here it is. Same parabola. This is x plus 2. Same line, x plus 2. Okay. Goes through 2 right there, right? Well, if these are the only two curves, then what is the region? What is the region bound by the curves? And again, it'd be nice if we were live in person together, because I could point to different areas and be like, is this it? Like, is this the region right here? Is that the region? Is this little section the region? Okay, so no, it's none of those. It's just what's between these curves. So it turns out they cross, right? So it's all of this. Maybe some of you are like dying, like, obviously it's that region. Okay, can we move on? I've been teaching this class too long to assume anything. Where were you 10 years ago? I was teaching this very same stuff, okay? All right, so we get this kind of cool little sort of curved sort of slice there. Now what's important, before we can set up the integral, we need to know where do those intersections occur, because that's going to tell us where to start and where to stop our integral. Okay, those two x values. So we can't even set up the integral yet. We got to figure out where these are. Now you might be able to tell graphically. Just looking at the graph on Desmos, you might be able to see very clearly where these occur. If that is the case, then just use the graph. Figuring out these numbers, that's not calculus, right? I don't care how you do it. If you figure out these numbers simply graphically, I'm fine with that. You don't have to show any work. But let me show you the work anyway, in case it's a more difficult situation or maybe it's not clear even graphically. Okay. Here's what we can do. Hey, where they cross, that's where the two equations are equal. So, okay, here's the question, right? At what x values do the curves cross? We need to set them equal. Where does x squared equal x plus 2? If I solve that, that'll give me the 2x values. How do I solve x squared equals x plus 2? Well, it's a quadratic. I should subtract everything to one side. Turns out I can factor that. And I know I'm going through this kind of quickly, but okay, so it factors nicely, and then set each factor equal to 0, and then we get our 2x values. X equals 2, and x equals -1. So I can go back up to my drawing and put in -1 and 2 right there. And now I know where my a and my b for my integral, what they should equal. Let me just reiterate, maybe you could tell these x values clearly from the graph, and it wouldn't be hard to check, like, Even if you weren't sure, you'd be like, 2? Oh yeah, 2 squared, that's the same as 2 plus 2. Yeah, I mean, that's where they cross, right? I mean, you can verify these things pretty quick. But if you want to do the work, hey, there's nothing wrong with showing a little more work as well. Again, you don't have to show any work for these. What I do need to see, though, is the setup for your area. So area equals, hey, there's the -1 to 2. And again, the top function, just like before, is the line, top minus bottom, x plus 2 minus x squared. Well, we already went through this very expression there that we're going to integrate. Well, let's do it again. So I wrote it as -x squared plus x plus 2. Take your antiderivatives, right? It's the same thing as before. The only thing that's changed are the a and the b. So we're going from -1 to 2. Let me just keep this out so we can follow the steps. Then what? Time to plug in. Plug in the 2. Boom, boom, boom. Plug in the -1. It's a long, this particular problem, it's got the 3 terms, right? So it's a pretty long to write all that. But hey, you know what? Even the most sophisticated math, sometimes you just got to crunch some numbers. Well, I think I broke this into 2 parts because I didn't want to attempt it all at once. So I did that number right there and then that number separately. And I got these for that first group with 2, I got 10/3 minus, and for this thing over here, I got -7/6. So my final answer was, when I subtract them, I just did that in a calculator, of course, I got the area equals 9/2, 4.5. Wow, 9/2 for that curved area. That's pretty cool. Who would think it comes out so simple? Okay, let's stop this video right here. We got another one coming next video.